A 30-amp breaker can be used for lighting loads under certain conditions. The National Electrical Code (NEC) specifies requirements for lighting. Lighting loads are typically calculated at 3 watts per square foot for general lighting. However, for a parking lot, the NEC allows for a maximum of 5 watts per square foot for lighting. Considering a 1000 watt lighting load, the current draw differs based on the voltage system. For a 120 volt system, the current draw is 1000 watts divided by 120 volts, equaling 8.33 amps. For a 208 volt system, the current draw is 1000 watts divided by 208 volts, equaling 4.81 amps. For a 480 volt system, the current draw is 1000 watts divided by 480 volts, equaling 2.8 amps. A 30 amp breaker can handle up to 30 amps of current. Based on the calculations, a 30 amp breaker can handle the 1000 watt lighting load for all 3 voltage systems that include 120 volts, 208 volts, and 480 volts. Firstly, for 120 volts, the load current of 8.33 amps is less than the breaker capacity of 30 amps. Secondly, for 208 volts, the load current of 4.81 amps is also less than the breaker capacity of 30 amps. Thirdly, for 480 volts, the load current of 2.8 amps is well below the breaker capacity of 30 amps. Therefore, in this specific situation, it is acceptable to use a 30 amp breaker for the 1000 watt lighting load for all 3 voltage systems. It's crucial to consult with a qualified electrician to ensure the circuit is designed and installed safely. Also, consider the future expansion of the lighting load and use a breaker that provides sufficient capacity for potential growth. The NEC Article 210.23 addresses permissible loads for branch circuits. Specifically, a 30 amp branch circuit is permitted to supply fixed lighting units with heavy-duty lamp holders in other than dwelling units or infrared heating units. This means in a commercial or industrial setting, a 30 amp circuit can power lighting fixtures that use heavy-duty lamp holders. Heavy-duty lamp holders are typically those that use mogul-based lamps, which are commonly found in high-wattage lighting applications, such as parking lots or warehouses. However, it is vital to ensure that the total load connected to the 30 amp circuit does not exceed 80% of the breaker's rating when the load is continuous. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. In such cases, the maximum allowable load on a 30 amp breaker is 24 amps, which is 80% of 30 amps. This derating is necessary to prevent overheating of the breaker and conductors. Furthermore, the conductors supplying the lighting load must be appropriately sized for the 30 amp circuit. According to NEC Table 310.16, conductors must have an ampacity rating sufficient to carry the maximum load current. For example, if using copper conductors with a temperature rating of 75 degrees Celsius, a number 10 American wire gauge copper conductor would be suitable for a 30 amp circuit, provided that the termination temperature limitations are observed. It is equally important to consider voltage drop in the circuit. Excessive voltage drop can cause lights to dim and can damage equipment. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% overall from the service entrance to the farthest point of utilization. To minimize voltage drop, a conductor should be sized appropriately, taking into account the length of the circuit and the anticipated load current. In addition to the NEC requirements, local codes and regulations may impose further restrictions on the use of 30 amp breakers for lighting loads. It is essential to check with the local electrical inspector or authority having jurisdiction (OJ) to ensure compliance with all applicable requirements. The type of overcurrent protection device, that is the breaker, must also be appropriate for the application. Circuit breakers are available in various types, including thermomagnetic, electronic trip, and instantaneous trip. The selection of the appropriate breaker depends on the specific characteristics of the load and the desired level of protection. Thermomagnetic breakers are the most common type and provide overload and short circuit protection. Electronic trip breakers offer more advanced features, such as adjustable trip settings and ground fault protection. Instantaneous trip breakers are designed to trip very quickly in response to a high fault current. When using a 30-amp breaker for lighting loads, it is crucial to ensure that the lighting fixtures are properly grounded. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. The grounding conductor must be sized appropriately and connected to a grounding electrode system that meets the requirements of the NEC. Moreover, it is essential to consider the ambient temperature in which the circuit breaker and conductors are installed. The ampacity of conductors is affected by temperature, and it may be necessary to adjust the conductor size or direct the breaker if the ambient temperature is high. The NEC provides tables and guidelines for adjusting ampacity based on temperature. Surge protection is another important consideration when using a 30-amp breaker for lighting loads. Lighting fixtures, especially those containing electronic components such as LED drivers, are susceptible to damage from voltage surges caused by lightning strikes or other electrical disturbances. Surge protective devices, SPDs, can be installed to protect lighting fixtures from surges. SPD should be selected based on the voltage and current rating of the circuit and the expected level of surge activity. Furthermore, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that conductors should be properly supported, terminated, and labeled. Wiring should be installed in accordance with the NEC and should be free from defects that could compromise safety or reliability. Proper labeling of circuits is essential for identifying the purpose of each circuit and for facilitating maintenance and troubleshooting. The NEC requires that all circuits be clearly labeled at the panel board. The label should indicate the load served by the circuit. In summary, using a 30-amp breaker for lighting loads is permissible under certain conditions, as long as the installation complies with the NEC, local codes, and good engineering practices. It is essential to perform the necessary calculations to ensure that the load current does not exceed the breaker's capacity and that the conductors are appropriately sized and protected. Consultation with a qualified electrician is highly recommended to ensure a safe and reliable installation. Also, it is worth noting that using a 30-amp breaker might be overkill for a single 1000-watt light. The purpose of using a larger breaker is typically to accommodate multiple lighting fixtures on a single circuit within the allowable load limits. If the intention is to add more 1000-watt lights to the same circuit in the future, then a 30-amp breaker might be appropriate, provided that the total load does not exceed 80% of the breaker's rating for continuous loads. However, if there are no plans to add more lights, then a smaller breaker, such as a 15-amp or 20-amp breaker, might be more appropriate. Using a smaller breaker can provide better protection for the lighting fixture in the event of a fault. For example, a 15-amp breaker will trip more quickly than a 30-amp breaker if a short circuit occurs in the lighting fixture. This can help to prevent damage to the fixture and reduce the risk of fire. In addition to the size of the breaker, it is also important to consider the type of lighting fixture being used. Some lighting fixtures, such as those containing electronic ballasts or LED drivers, may have high inrush currents when they are first turned on. Inrush current is the momentary surge of current that occurs when a device is initially energized. If the inrush current is too high, it can cause the breaker to trip. To avoid nuisance tripping, it may be necessary to use a breaker that is specifically designed for use with lighting fixtures that have high inrush currents. These breakers are typically labeled as HID or SWD, which stands for High Intensity Discharge and Switching Duty, respectively. Furthermore, the location of the lighting fixtures should also be considered when selecting a breaker. If the lighting fixtures are located in a wet or damp environment, such as a parking lot, it is essential to use a breaker that is rated for use in wet locations. These breakers are typically labeled as WP for weather protected or WR for weather resistant. They are designed to protect against corrosion and moisture damage. In addition to the technical considerations, it is also important to consider the aesthetic aspects of the lighting installation. The lighting fixtures should be selected to provide adequate illumination for the parking lot while also being visually appealing. The color and intensity of the light should be appropriate for the environment and should not cause glare or light pollution. The placement of the lighting fixtures should be carefully planned to ensure that the parking lot is evenly illuminated and that there are no dark spots. In conclusion, using a 30-amp breaker for lighting loads is a complex issue that requires careful consideration of various factors, including the NEC, local codes, the type of lighting fixture, the location of the lighting fixture, and the aesthetic aspects of the installation. Consultation with a qualified electrician is highly recommended to ensure a safe, reliable, and aesthetically pleasing lighting installation. Also, when calculating the load on a circuit, remember to include not only the wattage of the lighting fixtures but also any other loads that may be connected to the same circuit. For example, if the circuit also supplies power to receptacles or other equipment, the load of these devices must be added to the lighting load to determine the total load on the circuit. The NEC provides guidelines for calculating the load of various types of equipment. For example, the NEC specifies that receptacles and dwelling units must be calculated at 180 volt amps per outlet. This means that each receptacle is assumed to draw 1.5 amps at 120 volts, even if the actual load is less. This is to ensure that the circuit has sufficient capacity to handle the anticipated load. The same logic applies to commercial and industrial settings, with specific requirements for different types of loads. The NEC provides detailed tables and guidelines for calculating the load of various types of equipment, including lighting, receptacles, motors, and appliances. When calculating the load on a circuit, it is important to use the appropriate demand factors. Demand factors are used to reduce the calculated load to account for the fact that not all devices will be operating at their maximum load at the same time. For example, a lighting system in a large office building may have a demand factor of 80%, meaning that the calculated load can be reduced by 20%. The NEC provides demand factors for various types of loads. Using demand factors can help to reduce the size of the conductors and overcurrent protection devices required for the circuit, which can save money and reduce the overall size of the electrical system. However, it is important to use demand factors carefully and to ensure that the calculated load is sufficient to handle the actual load under all operating conditions. Another important consideration when designing a lighting system is the control of the lighting fixtures. Lighting fixtures can be controlled manually using switches, or automatically using timers, occupancy sensors, or photocells. Automatic lighting controls can help to save energy by turning off lights when they are not needed. For example, occupancy sensors can be used to turn off lights in unoccupied rooms, and photocells can be used to turn off lights when there is sufficient daylight. The NEC provides requirements for the installation of lighting controls. For example, the NEC requires that all new construction include occupancy sensors in certain types of spaces, such as restrooms and storage rooms. The use of lighting controls can significantly reduce the energy consumption of a lighting system and can save money on electricity bills. In addition to saving energy, lighting controls can also improve the comfort and convenience of the occupants of a building. For example, dimming controls can be used to adjust the level of lighting to suit the needs of the occupants. The NEC also addresses emergency lighting requirements. Emergency lighting is required in many types of buildings to provide illumination in the event of a power outage. Emergency lighting systems typically consist of battery-powered lighting fixtures that are automatically activated when the normal power supply is interrupted. The NEC provides detailed requirements for the design and installation of emergency lighting systems. For example, the NEC specifies the minimum level of illumination that must be provided by emergency lighting systems, as well as the duration for which the emergency lighting must be maintained. Emergency lighting systems are critical for ensuring the safety of occupants during a power outage. The NEC also addresses the use of renewable energy sources, such as solar power, for lighting systems. Solar-powered lighting systems can be used to reduce the energy consumption of a building and to save money on electricity bills. The NEC provides requirements for the installation of solar-powered lighting systems, including requirements for the interconnection of the solar power system to the electrical grid. Solar-powered lighting systems are becoming increasingly popular as the cost of solar panels continues to decline. Finally, the NEC provides requirements for the maintenance and testing of lighting systems. Lighting systems should be regularly inspected and tested to ensure that they are operating properly and that they are safe. The NEC provides guidelines for the frequency and scope of these inspections and tests. Regular maintenance and testing can help to prevent problems with lighting systems and can extend the life of the lighting fixtures. By following the requirements of the NEC and by consulting with a qualified electrician, you can ensure that your lighting system is safe, reliable, and energy efficient.